Hey guys, my name is Jan and I'm from DoraHacks, and welcome to our first workshop of the Nibiru Cataclysm Hackathon. And before we start, let me give you some background of this hackathon. As the largest Web3 multi-chain developer incentive platforms, it's an honor for DoraHacks to support this hackathon. And we're looking forward to all the amazing projects building on top of Nibiru. And today we have here Nino. He does a workshop about deploying Nibiru smart contracts, and he's a front-end engineer and DeFi. If you guys have any questions in the meanwhile, please drop them in the YouTube or in the Binance live chat, and also feel free to subscribe to our channels because there's also more sessions, and at the end the closing ceremony. So once you're ready, feel free to start.
Awesome. Yeah, I can get started. Thank you for the introduction. So yeah, let me put up the slides real quick. And here we go. All right. So to get you guys, if you guys don't know what this is about deploying smart contracts on the Nibiru chain. It's going to be the first of a few technical workshops. In terms of the agenda, we're going to be going through the introduction a little bit, what about Nibiru chain, and then we're going to talk about technical and knowledgeable stuff about what are smart contracts, how they work, some core concepts, and then we're going to go into we're going to dive into some Nibiru smart contracts and see how we can deploy them, and then see how we can interact with them, either instantiate, query, store, and execute, and then we'll have fun through it. All right, so we're going to get started. So what is Nibiru Chain? If you guys aren't aware, Nibiru Chain is a layer 1 blockchain that's built on the Tendermint protocol and built off the Cosmos SDK, and is designed to facilitate decentralized application and smart contracts. It is built to provide a secure and a scalable environment for developers to build and deploy blockchain-based solutions. So this is us, and I hope you guys have fun during the hackathon. So let's dive straight into it. So what is a smart contract? So smart contract is basically a piece of WebAssembly bytecode deployed on Nibiru chain. This bytecode contains the logic and the handling transaction and the state changes according to the rules defined in the smart contract. Now, the way that these smart contracts add this logic is using a framework called Cosmos framework, which is basically a set of tools, libraries, conventions for developing smart contracts on Nibiru. Cosm smart contracts are written in Rust, which is the system's programming language, and compiled straight into WASM bytecode. Once deployed, these smart contracts can be interacted with and by users through transactions which trigger the execution of specific functions within the contract, which are known as entry points. We'll talk about those later in the demo. These entry points can update the contract state, perform computations, and even emit events. So Cosmos contracts are being complied to WebAssembly, and then right after they be run on Cosmos virtual machine, and then that's when they get added to the chain. Now, there's a lot of good benefits that Cosmos brings us, mainly two, which is security and efficient execution. So Cosmos offers defense against re-entry and denial service attacks, along with compile time checks for overflow and underflow issues. We'll talk about that a little bit more later, but it makes it ideal for secure smart contract development. And then given that Cosmos runs on a sandbox environment, it ensures that there's no harm to the host system or access of unintended data. And obviously the use of Rust, which is a memory safe language, further enhances the security. And in terms of efficient execution, the performance on Cosmos is is almost near native, actually, because it leverages WebAssembly, which results in very faster transaction processes. And then that leads us to the next topic. What is WebAssembly? So WebAssembly was initially created to improve web performance, though it's no longer primary use for web development. WebAssembly, which is the abbreviation of WASM, is a binary instruction format for a stack-based virtual machine. WASM is designed as a portable, compatible target for programming language, which enables deployment on the web for client and server applications. For our case, they will be used to deploy smart contracts onto the chain. WebAssembly code can be generated from languages like C, C++, and Rust, and then it allows developers to write critical parts of their application in those languages, and then those get compiled into WASM for execution later on. But then why WASM? Well, as I mentioned before, there's performance security, but other reasons is it's minimalistic. It has a formal spec that fits on a single, it's very small. It can fit on any chain, any block. It's deterministic, and also it's widely accepted and used throughout various chains. So by learning WASM, by using it, you're able to access not only Nibiru, but several other chains as well. Now, WASM contracts have a really benefit because it would learn from the mistakes that Ethereum had before. So it's able to mitigate some common attack vectors that were presented on Ethereum. So one of them being the re-entrancy, which is using atomic message execution, where contracts responses with messages rather than calling into each other. So basically, when you perform a contract, it basically calls other contracts within each other. This is disabled in CosmWasm because it leads to unexpected behaviors. So CosmWasm doesn't allow the calling of other contract directly, but instead it sends messages that will be dispatched by a router at the end of the execution. Another thing that it does, it mitigates short address attacks at compile time. So basically short address attack occurs when a smart contract or application does not properly validate the length of incoming addresses. So CosmWasm automatically validates that. And then one of the most important ones is that contract storage is explicit rather than implicit. Since Rust does not allow initialized variables, storage is explicit rather than implicit. Okay. And then the final three is that there's no delegate call logic, meaning that contracts run as a single unified piece of code without external dependencies. So you don't have to wait on other dependencies to run your contract. This makes it more secure, easier to audit, and less prone to unexpected behavior. It also mitigates arithmetic overflow and underflow errors at compile time. This means that developers are required to use the safe math operations and for any arithmetic calculations involve token transfers, balances, or other critical financial operations. There's never a volatile state when a contract is called. CosmWasm particularly useful for safe production grade dApps. It's currently used into a lot of Nibiru Chain applications in terms of Nibiru Stargate, as well as our previous DEXs, and more ecosystem products are using it. Now for the dev setup. So to enable yourself to use CosmWasm, you need three things, ideally. Rust, the Nibiru CLI, and some Nibi tokens to deploy and to interact with your tokens, or interact with your contracts. We'll go through the setup for all three at the end of the demo, but just to let you guys know that you need only these three things to set it up. Now, most of you guys are probably coming from Ethereum, so I just wanted to do some translation from what Ethereum used and what is being used in Nibiru Chain. So Solidity is the version is translated into Rust, meaning that like instead of using Solidity, you'll be using Rust here. Instead of using Open Zeppelin, you'll be Nibiru Standard Library or CosmWasm Plus. And then instead of using an EVM, you would use a WASM EVM. And then instead of client side TypeScript or JavaScript Web3, you would be using Nibiru.js or Cosm.js. Now let's go over some core concepts for smart contracts on WASM. So the main three entry points are instantiation, query, and execution. So instantiation is the entry point that is called when a smart contract is first deployed. So after the smart contract is stored onto a chain, it needs to be instantiated and basically initializes the contract state so it can perform any necessary step. For example, it can set up initial variables, define initial permissions, or initial states value, which we will see at the end of the demo. And then the second entry point is going to be a query. So the query entry point is used for handling messages that request information from the contract. So unlike the execution function, the query function cannot modify state. Instead, it's used to retrieve data from the contract. As the name said, it's just used for querying. So they're only read-only operations and typically used to provide information. Now, the execute is one of the most important ones. What the contract what handles the messages that can modify the state of the contract. So when transaction is sent to the contract, it is processed by the execution function. So it can be stuff like modify the state, send tokens, mint something, burn some tokens. It can be things like that. these execute functions is where the core logic of the contract resides. Now, other two features of the Cosmos contracts is the state, which I kind of mentioned a little bit. So it refers to the data and variables that are stored under the smart contract. And these represent the current conditions and the status of the contract. And they can include stuff like the balance, the ownership details, anything that can be stored, basically can be stored in that section. And then for the events are messages. Events are messages that a contract can emit to inform external actors about actions or changes that have occurred within a contract. For instance, say a contract has been executed, but you want to relay who executed it, or the changes, or what was the previous state, or what's the future state, or the computations that was performed. So you can relay all these informations in the events in the forms of attributes. And we also go over that. And now that we're done, the technical and the logical stuff, we can jump into the demos. So we're going to start out with looking into the CW Nibiru Rust monorepo. And then we're going to look into creating the fungible tokens and how we can leverage the Nibiru standard library. And then finally, if we still have time, we'll go over the contract ownership. And so, yeah, so I'll just share my screen. Awesome. All right. All right, so to begin with this, I wanted to first introduce our docs, because most everything that we've talked about in our docs are present. Sorry, everything that I talked about in the presentation are present in the docs. So if anything that lost tracks or any specific information that was required, they'll be found here. Also in terms of setup, which we'll go over, but everything can be found in the docs. So before we step into anything, let's first do the initial setup. So like I mentioned, the only three things are required to set up Cosmos is Rust, Nibiru, Nibiru CLI, and then some tokens. So let's start with those. The first thing you would need is to basically install Rust. And so this is I'm not going to go into too much details on how to do that because it's going to be on their Rust website, but this is just a simple command, a curl command that allows you to do it. If you by any chance have already installed Rust onto your computer or your operating system through other means like Homebrew and sudo apt install, you might get some environment variable issues. You can try to resolve those or just uninstall and then install it via the URL link, the curl link, I mean. And then after that, the next step would be to set up your CLI, Nibiru CLI. Let it go. It might take a little bit of a while. Okay, and then we can do that. All right, and then to double check, you can check the version of each. So yeah, that should be good, and that should be good. All right, awesome. Now that you've done those, the last step that you need is to get some tokens. So to get the tokens, you have to basically have a wallet address. So with Nibiru, or actually with Cosmos contracts or accounts in general, you don't need to have a private key to be an account. You just have to have a public key and some funds. So technically, contracts are also accounts as well as like wallets. So that means that you can send money to those contracts, and basically they can send as well. But for now, let's just stick to creating a local wallet and then getting some funds into it. So we can go into here, and then we can access the Nibi keys and faucet, and let's follow through the guide. Let's add workshop. All right. So now that we have a, this is going to be just for test purposes. Now that we have a mnemonic, you can grab that mnemonic and add it to your browser extension wallet. It can be Leap or Kepler or whatever you tend to use. For my case, I mean, I'm going to be using Kepler. Let me see if I can bring it up. And then the way to add it is you can just simply go here, you can add a wallet, importing existing wallet, use recovery key, and then boom, and then you import it. Let's call this Nibiru workshop. Awesome. Let's add Nibiru. Awesome. And now we can go ahead and then we have it set up here already. So we can go into testnet 1, which is the most stable testnets, and then we can request some funds. And boom, there we go. Now let's double check that our funds have went through. We can actually query the balance using Nibiru CLI. And we can just grab the address from here. Oh, did it not get through? Oh no. Okay, let's try another test now. Oh, I believe I'm in the wrong test now. Yeah, so let me go to the correct one. There we go. Oh man, I ran out of funds. Okay, I guess for now, there's some restrictions on how often you can use your faucet. We don't want people to abuse it, but for the cases that people don't have first time trying it out, they'll be able to receive it. For now, I'll just use another test wallet that I have, but it should work just fine. This one I believe has funds. So awesome. All right. So now that we have funds on this one, let's we should get started. All right. So next up, let's look into the Nibiru's CosmWasm monorepo right here. All right, yeah. So this repo is basically holds all of the CosmWasm contract that's currently used throughout Nibiru, and it's made in a specific format that is very easy to use and very intuitive. So you don't have to worry about handling builds and optimizers and things like that separately. It can all be done within it. So for instance, say after you've cloned the library, let's put it, clone the repo. All right, you should be able to just run just, and then this will show you all the available commands that you can use to build, format, lint, and even fully optimize and create your smart contracts. And then in the process of this repo, you can basically create another smart contract over here. And then as you do, you would be able to leverage all the packages and the Nibiru standard library, as well as all the dependencies that are installed within the workspace. So this makes it a little bit easier for for creating your smart contracts, because it's created as a template that you can run through. And yeah, I'll actually open it in Visual Studios and show you guys a little bit more. Let me do that. All right. All right, so there we go. So here we can see all the contracts that are available. And say we suppose we want to build some of them. We can just simply do just, there we go. Oh man, let's go. No. Okay, let's do it again. Oh, the Rust analyzer is running. Yes, this is a pretty cool tool to analyze it. It just takes a while. Let me close this up. All right, should be good to go. All right, awesome. All right, so yeah, so you can use build to update to build your contract, or you can just do wasm all, which basically not only builds it but also optimizes it. And the reason why we optimize them is because when we want to upload them to the chain, we want to make sure that they're as small as possible so that they cost the least amount of gas when you want to upload them and then interact with them as well. So let's do WASM all. See. Yeah, so this is just optimizing. Yeah, so now this just builds the contract that exists. Okay, all right, yeah. And it goes through the process of compiling them, and then it's going to open a Docker, run a Docker container to optimize them, and then you would have your artifacts of fully optimized contracts in your artifact folder. For the sake of time, I'm going to just these already pre-run, so we can go ahead and try to deploy the Nibiru Stargate. So the Nibiru Stargate, it allows you to create fungible tokens that are also IBC compatible. So if you can go, don't break on me now. All right, there we go. All right, so you can access the README file. You can see the specifications on what sort of messages are we sending to those contracts to interact with it, such as minting, burning, and creating denominations. Yeah, there we go. Okay, all right. All right, and I'll just close Visual Studios for now, and I'll do it on the terminal since you don't need to see Explorer anymore. Okay. All right, there we go. Okay, so now that we're over here, let's look into how we can deploy and fully interact with the Nibiru Stargate contract. So Nibiru Stargate contract, we can see from the documentation, it allows us to do four execute functions. So create a denomination, mint it, burn, and change the admin of the token that we're gonna create. So in terms of how to create the smart contract, we'll go into that later on after we showcase how we can deploy and mint those tokens. But for now, the idea is that we send those JSON formatted messages to the contract as we execute it, and then with those executions, we basically trigger the execute function that we talked about previously, which is the entry point on the smart contract. So let's go to the C Nibiru. All right. So the first thing we want to do is we want to make sure that we are set up on the correct chain, testnet 1. Awesome. And then next we want to preset our wallet so we can easily call it later. So this is the wallet that I'm currently using, and it does have funds. Yep, over here. Let me use on testnet 1. Yeah, we do have some funds. Awesome, great. Now the next step is that we want to do, and again, this is all documented in our docs over here. I'm actually going to open them here so they can easily be read. Yeah, the first thing we want to do is basically store our contract onto the chain. So we can run this command. So the idea is that we use Nibiru CLI to trigger a transaction using the WASM module to store the artifact, which is going to be the bytecode itself. So we can access the bytecode, and I believe it's going to be Nibiru Stargate WASM. All right, there we go. And then next, we want to set up the from, so who is the sender, which is going to be us. I preset it over here initially, so we have that figured. And now we want to set the gas. So for the gas, we usually set it to auto, but you can specify the fees if that suits you. But the minimum is usually about 0.025 micro Nibi. Micro stands for like 1 to the power 6 of a Nibi. So basically every 1 million micro Nibi is 1 Nibi. And then the gas adjustment. Gas adjustment is usually 1.5, but it can vary sometimes. For now, let's run it as so, and let's see what it looks like. So after storing the Cosmos and bytecode onto the chain, we get returned a transaction hash. So if we create this transaction hash, we can actually obtain more information about what actually happened when we did that. Okay. We did. Yeah. There we go. All right. Load. Okay, awesome. Yeah. So we can see exactly what happened. So we can see through these events and logs. So here we have the bytecode itself. Yeah, it's quite large, but we can see messages like who were we sent. So who was the receiver of our gas fees that we sent to basically upload store our bytecode to the chain. And we can also see, more importantly, the code ID. So the code ID is what used to basically identify what smart contract is going to be used later on. We want to instantiate it. So we can preset that. So we know it's 529. So we can code ID 529. And then next step, we need to instantiate our contract. So instantiating our contract follows a different command, but it's pretty similar. The main difference is that we would need to send the instantiation message. So that varies depending on the smart contract implementation. But for this example, we're gonna do the con ID, and then we're gonna, and then for this example, we're using the Stargate. We would be using there's not gonna be any instantiation message. It's gonna be empty. So we need to send it an empty JSON. And then let's specify it, call it workshop. That's fine, and give the same gas fees. All right, there we go. And then now, given that we have this new transaction hash, we can simply query it to obtain the contract address. And again, we can see more details about what occurred in the hash itself. All right, so we can see that it's been instantiated through us module as WASM, and then we can see that we have the contract address. Now you see the section which says attributes, and these are all events. And when I mentioned previously that we can add on to these events, and when we write a Cosm WASM contract, that's exactly where they would appear. So if you want to basically, after instantiation, you want to add more information, like for example, who's the owner of the contract. If for instance, you want to store some data initially, those events will be added into here. And then those attributes that you would add to those events will be showcased on the transaction hash itself when it's being queried. So for now, we want to get the contract address. So let's do contract address. All right, there we go. So now we have the contract address. Now we can interact with the Nibiru Stargate contract, and then we can see in the docs here that we can either mint, create denominations, burn, and change admin. So let's try to create a denomination first. So let's do So now that we want to execute, sorry, I missed that part. Yes, now that we want to execute, we want to run Nibiru transaction wasm execute on it. Execute. And then here we remember that it was create denominations. Like you can set that up. Create denom. And then the subdenom for this example, let's set it to newbies. Awesome. And yep. Okay, yeah. So you see how this process is very complicated to set up every now and then. So what we can do instead is we can actually save this into another file. So let's actually echo this message, this JSON. Into instantiate.json. Oh no. All right, there we go. echo instantiate.json. So now if you cat it, .json, we should be able to see it, and then that's good. So now we can just simply do Nibiru Cataclysm, execute address, and then here we can just oh man, I'm switching between languages here. Cat instantiate. Oh wait, hold on. I think I have the command, so we don't have to spend too much time on it. Right, there we go. Oh man. Cat, there we go. Instantiate. Oh, sorry, it was instantiate. It's create denom, but we call it instantiate. Whoops. Let's actually bring it back then. Call it create denom JSON. Awesome. There we go. Nibiru. Where was I? Text wasm. Execute. Execute. All right, there we go. Contract address, and then okay, cat create denom, and then we can simply add to the rest the execute function, which is the from and the yes, the guess extensions. Oops. Hold on, we did it wrong. Oh, yes, was incorrect. Let's take it off. From gas auto to gas adjustment 1.5. Oh, yeah, there we go. All right, so there we go. We created denomination. So now that we created denominations, oh, what did I miss? Oh yeah, I missed the gas prices itself. Gas. There we go. There we go. So then we have the transaction completed. So now that we have the transaction hash, let's oops. JQ. And then we can see that we created a token under the name of, under this address, which is going to be the contract address itself. So now let's try to mint some tokens. And for this example, let's actually rely on some Visual Studio. So let's do code this. All right, great. All right, there we go. So let's create some other JSONs. just loading 1 sec. There we go. All right, so let's call this args for the sake of this. Oh, man. Okay. All right, args. Boom, there we go. All right, there we go. So now we have arga. Let's name it again. So let's mint some tokens. Let's add that onto here. All right, great. So now that we have this over here, okay, I can just remove this. We don't need it for now. Let's actually use this to fill up how much we want. So let's say we want to mint 1 UniBeast. That's what I called it before. Let's get it back. Yes, so new UniBeast, yeah. So let's say we want to mint that. So we need to basically copy this format and add it onto here. And then let's mint to another address. So let me just get another address. There we go. Or actually, we can just utilize this address though, since it's different. So we want to mint to this address right here. So now that we have that, let's execute this. So Nibiru execute, execute, and this time let's give it a args. Oh, need gas info key not provided. From gas auto, adjustment, gas price. Let's do that. It's already saved this before. Mint args. There we go. Gas info not provided. Oh, let me try a different address. All right, let's try a different address. Kepler. Okay, there we go. Key not in. From Oh, I realized our from is incorrect. There we go. From is incorrect. Get execute contract JSON denominations NUBTF module. Let's find the error. Hold on. CW. All right, where was I? Where did we go wrong? Hold on, let's double check. So let's create the denomination again. Oh, let's do it again. All right. Create denom. Let's call it something like UB. All right, let's do it again. Need transaction. Execute, and then we're going to go from create denom gas info. Our contract was in. Press adjustments. And from UB. Okay. Oh, absolutely, yeah. From gas adjustments, and yes. Cat, create denominations, JSON. Okay, let's just start from scratch then. We'll do it again. Okay, Nibiru TX store. TX Wasm store artifact. Now that we have this, let's find the code ID. $330. Now that we have the code ID, let's instantiate it. So let's make an instantiation folder. Copy, rename instantiate args. All right, and let's add the instantiation, which is going to be just an empty string. Sorry, empty JSON. And let's do need tx wasm instantiate code ID, and then let's do workshop, and then we set it up. Okay, we get that back. Need query tx. Oops. Okay, need query tx JQ. Now that we have the contract address, get it again. Need. Let's set it up as so. Okay, now that we have that, go contract address. Great. Let's now instantiate the message. So let's run this command from the docs that we're pulling up. Bring this away. Oh. All right, let's set up the label though. Oh my God, man, this thing's so slow. Okay. Let's create a label. Let's call it Nibiru Stargate. There we go. All right, now that we have this, we have instantiated. So now let's try to create a denom again. Need tax wasm execute, create denom. Boom, there we go. I think what I did miss is I missed to instantiate it correctly. So now that we have created the denom, we can query this, and then we can see the denom being existing. JQ. All right, there we go, the UBs. Now let's try to mint some. So we add 1,000, and yep. Let's take the address and the UB. All right, and then let's mint it to this address. Let me double check I have that open already. If I do, all right, awesome. Now let's do that. All right. Need tax wasm execute contract, and then instead of this, let's change the argument to the mint args. There we go. Let's sign it. So now that we have sent the transaction, we can actually query this and double check that it worked. Need query tx JQ. All right, so now that we can see that it went through and it went by, so let's now see that let's query the tokens that this user has, or the basically their balance. So let's query their bank balance. JQ. And now we can see that the tokens have been minted to this user and their UBs. Now let's see if we can basically burn the tokens. So let's create another file. And let's rename it to burn args. And the burn args are as follow. And let's burn the tokens that we created. So we can just simply, this was 1,000. Let's take on the format, place it here. And then let's do the mint address. All right. So now let's burn away these tokens. So let's run burn. There's JSON. Yep. And then there we go. So now let's see if we can query the user's bank balance again. And oh, did I not go through? TXL, query hash broadcast. Oh, did I press no? Hold on. Clear. Burn. Oh, mint 2. Oh, I forgot to change everything else but that. So we just minted another 1,000. Let's just do burn. Burn from SO. Let's burn. There we go. Oops. Oh, man. There we go. Okay, so let's do it again and burn the rest. It's just, and we can query this to just double check that it worked. TQ. We did an event burn. Awesome. Let's see the balance. And the UniB is gone. The new bees that we created for them is gone. So this is how you would deploy this Stargate contract. Apologies for the confusion. I think my terminal was kind of slow, so it was like messing up. But we should be good to we should be back to go. And then that's it for this one. So let's now look into a customer contract that we've created, and we can try to add edits to, and see how we can interact with this. So let's get that contract. CD workspace. CD. Workshops, right? CD. All right, there we go. So let's look at this contract real quick. All right. So now that we've deployed the Stargate contract, let's see if we can work on other contracts and deploy them as well. And then see how we can leverage the Nibiru STD library to perform some actions. How are we doing on time? Okay, short on time. All right, so in this example contract, we're basically creating. So we're going to go through the lib over here. So this example contract, we were doing the three main entry points, which is the instantiate, the query, and the execute. And then through them, we're basically creating enums to allow us to create multiple functions. So let's explore basically the queries for now. So if you access the contract.rs, we can see that we've created four queries. So the hello world, the get price, the ownership, and the get count. So essentially, basically, these contracts, these queries that we created, to deploy them, we basically decide what's the JSON message that we want to send to them. The same way we ran through the JSON message for the Nibiru Stargate. So in our context, we can check what's the type for each one of them. So for the hello world, we just want an empty one. For the get price, we want to put a pair, and then we can actually look at the type of it. So we can, if we access the query message, we would actually see that it actually takes in a string, and then we can see the get count as well. Now, if we go back to the execute functions, so far we are going to be trying to implement if we have time. I don't know if we will, but if we can implement increment and the reset functions. But for now, let's just focus on the queries and the instantiation. So in the instantiation function here, we use something called the CW ownable. The CW ownable is basically a standard library, or just like a package that can be added to your smart contract that manages the owner of the smart contracts. And so basically, you provide that information on instantiation. It can be the sender, or it can even be like you can enter through a message. And basically, in the instantiation message you send to the contract, it will be added to. It will basically be parsed and then be given to the initialized owner, and then it will be set in that sorry, that address will be set as the owner for that. So let's just first try to play around with this one real quick and see what we can make. So the first thing, again, we need to do when we want to deploy contracts is we want to build it. So in the previous example that I showcased, the Nibiru Stargate was already built. But to build it without the mono repo, you would need something called the cargo build WASM32 unknown target build command. And so these are very standard. You can set them up in your config file, and then via those config files, you can later call via cargo WASM to build them. So let's do that. Cargo WASM, let's build the contract. All right. For a while. While it loads, it's only done. We need something also to optimize the smart contract, something that I spoke about before. It's basically a Cosm WASM Rust optimizer. It's briefly discussed in our docs as well. But basically, you basically spin up a Docker container and then mount your WASM code, and then basically it will generate an optimized version of it, and it will leave it in the RWAs file. So we'll let it run. In the meantime, yeah, so this is it. And then we can check out the repo for the Cosm WASM. Oh, I guess I didn't have it saved here. Oh, it's fine then. Oh, it's done already, so it's okay. You can hold off. So that's great. So now, again, to deploy, the first thing to do is we need to store the contract. So we're going to do tx wasm store. And in that case, we're going to have the artifact CW wasm contract. And then, oh, it needs the from. Let's set up from, which is this address. All right, boom. So now that we have the transaction hash, we can query it. And basically, you can create a script to automate all this, but I want to showcase step by step to show you like what exists under each event. But you can simply create a script that will like trigger this whole thing if you want. Query transaction. And in our docs, actually, we actually showcase a simple way to formulate through this. But the idea is that you can see that the code ID in the events, and then you can set it up. And the next step would be to instantiate it. So for the instantiation for this contract, if you can go back and see, it takes in instantiation message. It takes in a count that we give it. So let's see if we can do that. Clear, indeed. Tx volume instantiate code ID. Let's do it from scratch, actually. Tx wasm instantiate code ID. Actually, let's actually do it to the JSON file just to be safe. Touch instantiate.json. Count. Let's put a count of maybe 100. So, okay, Nibiru tx wasm instantiate code ID. let's get the command. Code ID, yeah. Oh man. All right, we're gonna do it this way then. Copy. All right, so let's edit this. Let's call this the workshop contract, and then this is called instantiate. See, just wanted was used about. Oh, did we run out of funds? Oh, did we not set up a from? Indeed. Query. Query. Oh, we have funds. Hold on. Query from instantiate. Oh, the instantiate mesh was incorrect. Processing type instantiate mesh invalid margin contract with gas wanted. Oh, so something an error with the contract itself. State. Again. Let's see what's going on here. Workshop. Instantiate code ID. Get instantiate. Oh. What? Okay. Count. Oh, I know why. Because this is a string. It's supposed to be a number. That's the issue. But we can do it here. 100. Let's do 10. Small. There we go. Clear. Need bead. Query text. Q. Now that we have instantiated the contract, now we can see that in the WASM events, we notice that we have new attributes like what was the action, what was the owner, and what was the count. Now those are the attributes that we were talking about earlier, where we can append to specific events, and those are what's added here. And then using these events, we can add more information. So in any case, we can just add the owner of the contract, which here is going to be the sender. Now let's try to query. Let's perform these queries and let's go over them. So let's do Nibiru query, or is it Q text? Oh yeah, query WASM. All right, there we go. I guess one is saved already. So the first one is the ownership, so it basically shows us the owner. What did I miss over here? Ownership was required something. Is there? Oh no, there's no contract address. Let's do contract address equal to this. All right, there we go. So now that we can see that we were able to successfully query the ownership. Now let's do the hello world. Hello world. Oh, it's gonna be with and then we can see that we got this message. Now, if you look into the code over here, we can see that we in this function we actually programmed it to say hello world, hello Nibiru developers, and then in the function that that gets the ownership, you guys notice that it's not there. And the reason for this is because using CW ownable, you're able to basically append to existing queries by by using the predefined queries that the C-ownable library already has. So that this is where this is performed. So this guy over here, for example, this macro, it adds the ownership related queries onto the enum, the query message enum. That's what allows us to automatically access it and not have to define it. And this is the reason why you don't see that over here. But yeah, and then these other functions, these other queries, you see them because we had to identify them. And yeah, this get ownership is already pre-made from the CW ownable. Yeah, so next step, let's look into the, what do we have here? Let's look at the get price. So the get price uses, this function is very interesting because it actually uses our Nibiru standard library to query stuff, to query Oracle prices. So currently, if you access our heart monitor, that's not monitor. Let's access heart monitor too, since I know there's more Oracle prices there. So the heart monitor will be discussed later in other workshops. It's meant to basically index the entire chain and also provide more information that the team has already worked on using basically a heart monitor GraphQL endpoint. So here we can see these are the GraphQL endpoints. So this is what we can basically query within the chain via the Nibiru STD, standard library. And the way to do this is basically to run Nibiru query, and then in this case we would do get price. Get price, and then we have to specify the pair, and let's specify. Let's get the UBTC and USD one. Oops. Okay. Now, before this works, the issue with this is not going to work is because the contract is actually deployed on testnet 1. Since the oracles are there are more oracle vowels on testnet 2, we'd have to basically redeploy the contract to run it on testnet 2. So let's redeploy real quickly. So first thing we have to do is we're going to set it up to Nibiru config testnet 2 instead of testnet 1. All right, and then now let's run through the deployment commands. The first step is going to be to store. So Nibiru transaction wasm store. Let's store it again. After the storing, you can access the TX hash. Again, the TX hash will show us more information. We can do is query TX hash JQ, and then here we can see the code ID. So let's set the code ID to 82. Given that, we can instantiate it. So if you guys remember how we instantiate, it's going to be via doing transaction wasm instantiate code ID, and then we can set up the count, which we can use later. And then we can use this maybe TX wasm. And then yeah, now that we have it instantiated, we can actually, let's take this code and then look at the arguments and the events and the attributes, that we've added. Wasm, query transaction JQ. And then we can see that we've instantiated correctly, and here's the contract address. Let's set up the contract address globally so we can use it multiple times. Oh, wait, contract address. All right, that's the same one. Awesome. All right, now let's do Nibiru transaction wasm. We're gonna do queries, right? So let's do. So we're basically trying to query right now. Yeah. So let's look at this, see if it's available. Awesome. Now let's do get price, and boom, and we're able to get the price. And so basically in this function right here, what happens is that we're creating a query exchange rate request struct. And then this is straight from our Nibiru STD library. And then from there on, we would convert it into a Stargate query. And then from the Stargate query, we would just run it through the dEpps, which is basically, our dEpps is basically allows you to contact or run queries outside of the smart contract. And in this case, we're running a query to our Oracle to obtain those prices. And this is how we get those prices. And I think because I'm running out of time here, I'm going to just do one more, which is going to be just the count, the get count. And the get count will follow the exact same thing. The get count will give you the count that we initially instantiated. So this would cover mostly like what happens onto the state. So if you look at the instantiation functions, what we did here is we saved the count, the count that we sent into the instantiation message onto the state. And if we access the state, we can see where it's defined. So here was where we're creating the state itself. No, not creating the state, but basically where we're creating the struct for the state using the CW storage plus library. And then here is where we're saying exactly what we want to store in the state. We can add more information over here if we would like, but for the case of this this example, we were staying with just the number of count, and then that's it for deploying the contracts. We run through the ownable. I guess I think that's it. That's it for the demo for now. We can jump back to the slides and cover some questions. All right. So before we get to the questions here, or we'll be sending we'll be sending this entire slides out, so you can access all those links. But these are the main links that you would need to basically run everything. Notably, the main important one is the Nibiru docs, where we would have all this documented and step-by-step guide to get it set up. And then finally, yeah, that's it. Thank you guys for listening. And if you guys have any questions, feel free to ask now or ask them on Discord and Telegram.
All right, so thanks a lot for the insightful workshop and presentation. I think it was a lot and super cool that you showed how to deploy a contract, how to write a contract, how to mint tokens, how to burn them. Maybe let's give the audience some time. Like, as you mentioned, they can also reach out to you on Discord or the Telegram. Maybe you can let them know like how they can reach out to you.
Yeah, fair. Yeah. So the way you can reach out to me is via my Twitter at calico_Nino, or you can join our Discord, which will be provided on our app. And then you can, in our Discord, there's going to be channels where you can ask questions directly, or you can join our Telegram chat, where you can also ask us questions right there.
All right. So I think we are a bit over time. So like, once again, thank you so much for the insightful workshop. And if there's like anything else you would like to mention, please go ahead. Like if you forgot anything.
We're gonna have another workshop on Tuesday where we're gonna go over more about the Nibiru CLI as well as the Nib.js client-side library, npm package to allow you to basically create and interact with Nibiru Chain onto your front-end applications.
Okay, so thanks a lot, Nino, for the workshop. And as you mentioned, the next one is on Tuesday. So like, feel free to also subscribe to our channels and not miss out on the next one. And thanks a lot for this insightful workshop. And as I mentioned before, we're quite excited and looking forward to all the incredible projects building on top of Nibiru.
Yeah, awesome. Yeah, thank you so much for having us.
All right, thank you so much. Take care.
Bye.